Hi, my name is Karuka Athanisha Dini Jacob. I'm going to present about elastomers, subtopic from the topic of polymers. Before begin my presentation, I would like to thank our lecturer T.S. Rosaimi for giving me this opportunity to explain about elastomers from the class of Skmm 2713 manufacturing process. Okay, basically, elastomers is a type of polymer that have the ability to undergo a large deformation and return to their original shape when stress is removed. Besides that, elastomers known as rubbers and are widely used in many applications such as tires, gaskets, seals, and adhesives. Elastomers characteristic and structure. The structure of elastomers is characterized by a long coiled polymer chain that is cross-linked with other chain, forming a 3D network. Some scholars and books reference has been given an example of the structure of elastomers, which we can imagine as a spaghetti and meatball, in which the structure looks like a meatball and signifying the crosslinks. Elastomers characteristic also, it's a chain of typically weak and reversible, allowing the chain to slide past each another when the material is stretched, and then it returns to the original position when the stress is released. Elastomers are typically amorphous, meaning that they do not have well-defined crystalline structure. The absence of crystalline is due to the long coiled polymer chain that are randomly arranged in the material, and we can see the image below. So unstressed polymer and stressed formula. Once the unstressed formula has been stretched, and we can see the shape as a long line with as we say, like a spaghetti and meatball, which it elongates. Then once released, it will go back to the original shape. Okay, let's see about properties of elastomers. Okay, basically the property of elastomers is a very amorphous material where it wide and high randomly oriented properties, and it's a very big reversible extensions, and it has a low intermolecular forces in which it allows flexibility. And it is also a rubber materialistic. It can stretch to many times and return to their actual length or position. And it also can be bounced to its original shape without any permanent deformation, and it has a high elongation behavior. Basically, also it has a high elasticity, low modulus, low strength, good chemical resistant, poor heat resistant. Okay, why it called as high elasticity? Because it can undergo, as I told in a previous slide, it can undergo a large deformation, and then it can go back to the original shape. Okay, why it is low modulus? Low modulus because it has a low stiffness, which they can easily be deformed with relative low forces. Okay, low strength, it is because it has a relative low strength compared to other materials such as materials or ceramic. However, they can still withstand with significant forces without undergoing permanent deformation. And one of the properties also, it's a good chemical reaction where it is a very good resistant with a wide range of chemical, making suitable products for use in harsh environment. And it is a poor heat resistant because it has a very low melting point and can degrade when exposed to high temperatures. Okay, let's see the type of elastomers. Okay, they have many type of elastomers, but I just choose the basic elastomers for explanation. Okay, like natural rubber, usually they call NR in many scholar books, and they have polytrade elastomers, polybutadiene elastomers, and also nipron elastomers, where it's actually the basic, and and also silicon elastomers. It is the basic, and I added some of it where we have the dielectric elastomers and floral elastomers. Okay, let's see NR. A natural rubber. It used to automotive, normally automotive parts. They use in medical tube, balloons, and adhesives. Okay, polyurethane elastomers is used in textiles or manufacturing for elastic clothes wear. Okay, polybutadiene elastomers were resistant for wheel vehicle, for the rubber of the wheel, so it actually resistant for it. And silicon elastomers usually used in medical industry, food, automotive industry, aerospace, uh, and more and many more. because the silicon is composed of hydrogen and carbon, which can make a good stiff material, and it can be elongate easily and return to the original shape. Okay, and dielectric elastomers usually used for covering electrical energy. Sorry, used to convert electrical energy to mechanical motion. Fluoroelastomers is where specifically developed to possess exceptional resistance to a high temperature. Okay, next let's see the application of elastomers. Application of elastomers. Okay, there are elastomers can was been applied in many applications, such as in automobiles, where it because it have a high resistant melting point, so it can make valuable seals like for tires, and also like oil seals, and also it has ability to withstand wear, where it can long last for so many years. And for consumer goods, the group of encompasses widely variety products ranging from toys for infants and to rubber soles of numerous other unrelated items. Okay, and elastomers are used in constructions where the utilize elastomers containing sealants and adhesives is essential, especially for the effective filling and what do you call it, bridging cracks. Okay, in industrial product, also the elastomers has been used, where for belts, molds, lubricants, and many more. Wire and cable, especially to prevent any shock or any electric short circuits, because it have a well insulated property. Okay, in medical equipment, for biomedical usually they use more to silicon materials, and also for diverse array products. Okay, let's see the advantage of elastomers. Okay, elastomers basically have an excellent elastic properties, as we saw the previous slide before, and it actually poses a good sealing and insulation capabilities, such as for wires, as I told just now, for wires, and any prevention resistant. It actually have a good insulation, and it is a high resistant to wide range of chemical, and often exhibits a good resistance to weathering, so it can actually withstand weathers. Okay, and lastly, it poses excellent damping properties and vibration isolation. Okay, let's see the disadvantage. Okay, it has a low strength and a tear resistant, limited temperature range, can experience permanent deformation. Yeah, every material have their limits. Okay, and it have a sensitivity to environment factors. Yes, just now I was explaining it has a good it can withstand environmental factors, but in to a certain extent only. After that, it will wear and tear usually, and moreover, it has a limited design freedom. Okay, this is a reference where I used to see the definition to pick some of the properties, and also learn more about the elastomers. Okay, that's all. Thank you.